cloud engineers, DevOps engineers, solution architects, SRE, and GCP. So you first of all, we start from fundamental. Okay, that module one. What is cloud fundamental? On these topics. Then we go for a lab. Okay, on this module one. Next, we discuss about Google Cloud fundamentals, right? Or the whole resource hierarchy, buildings, and how to connect, how to configure, creating projects and all in module two. In module three, IAM, how to work with users, groups, policies, permissions. Yeah. In GCP, in IAM cost. Okay. Here you can understand users, roles, and permissions and so on. Next, we discuss about the virtual machine compute service. In this, we discuss about compute engine, virtual machine instance, templates, everything. What different types of virtual machine access and management. We want to discuss how to connect virtual machines and how to access them. In network module number 5, we discuss about complete networking part of GCP, how to create VPC, subnets, firewall, routing, NAT gateway, pooling, UDM, everything, load balancer, everything we discuss. And this is the lab. So this was the topic we discuss one by one. Okay. You are able to follow, right? Next.
Yeah.
Module 6 storage service. So in this, you're going to understand about the complete storage management of GCP and how to work with disk storage classes, file store, everything. Next, module 7, database service. In the database service, you're going to understand this is how you talked about SQL, Cloud Spanner, big table, file store, memory table, and LITD. So this you're going to understand about how to connect the SQL to work, how to manage. Then module 8, containers and Kubernetes. You're going to understand about the containers, like how to work with Kubernetes, GPE, Kubernetes Engine, pod, deployment files, the auto-scaling, there is secrets, config maps, everything. Please ask if you have any doubt up to this.
No, it's all good.
So then we discuss about serverless computing, like how to work with serverless, like cloud and cloud app, cloud functions, how to deploy serverless application. Then we move to DevOps part in GCP, how to work CI/CD pipeline, infrastructure support, how to work with build, deploy, source repositories. Next, monitoring and logging. We are going to understand about how to do the cloud logging, monitoring, alerts, and dashboards. Then security part. Again, we go for more in-depth of security of IAM, operation policy, SCC, then AMS encryption, TCC controls, and IDP. How to work with encryption. Next, big data. We want to work with big because GCP cloud is most popular for big data analytics. You want to understand about BigQuery, data flow, complex, Looker, cloud composer. Then machine learning, because nowadays clouds are coming with machine learning solutions. So you want to understand all this one. Module number 14. Then migrations, how to migrate the on-premises resource to GCP, server migration, database migrations, and what are the necessary steps you have to take. Then working on cost optimization, like how to reduce the cost in GCP cloud, how to make what are the ways that we can able to follow to reduce the cost optimization. Everything we discuss in module 16. In module 17, then we are going to discuss about Terraform, like how to build GCP Terraform and how to create infrastructure as a code. Next, we discuss about more on SRE topics in GCP, like reliability, high availability, SLI, SLO, SLO, and capacity planning, incident management. After completing these 8 modules completely, then we go for real-time projects. Okay? Totally 8 real-time projects you're going to get. Okay, in this one. And then if you want, you can complete certification. So this is how the roadmap. You have any questions?
Yeah. I think I just have like certain so this is a lot of these might be too in depth for me, and just again I kind of have touched upon like what I do. Where I want to use it is in marketing analytics, right? So 40, maybe it's 50-50. 50% of the job is campaign planning, strategy, etc., and 50% is mostly like marketing measurement, right? So you're pulling that data, you're processing it, stuff like that. So concepts such as like security in a big organization, there's going to be somebody taking care of security because they are in depth and they're very knowledgeable and stuff like that. So the two modules that I have written down is module 7 and module 13, right? Like those are like extremely important topics for me. When Yeah, if you can go to module 7, you see database services, right? Like Cloud SQL, Bigtable, Firestore, like stuff like this is definitely important, but more important than this is module 13. So this is the thing, right? Data flow, data BigQuery. So the thing is, I think BigQuery, that is where we should start, right? Like just to see if you can walk through that topic today, that would be great.
Okay. Okay. So you want a small demo on queue, right?
Yeah, BigQuery, yes.
Okay. Okay. So give me a minute. Okay.
Yeah,
I
yeah,
will prepare uh, 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 the diagrammatic. Okay.
yeah. Okay. Yeah, yeah. I'm here. I'm here. You can come back to me.
Okay. So let us explain.
Yeah.
Okay, actually, this one is a GCP BigQuery is a fully managed and is a serverless. Okay. Then for and highly scalable cloud data warehouse. So we use for cloud data warehouse, and it is designed to store, a massive amount of structure and semi-structure data using SQL.
Yep. So basically, from this, what I'm understanding is before before Google Cloud Platform existed, you could write like a SQL. SQL would be its own software, which is on your computer. You can use that to connect to a cloud platform that is owned by somebody else, right? Like there's a different storage, and you could write the query here and reach to the different storage and then pull that data for any of your analytics needs. But what Google has done is that they have taken care of all of that. So there is Google storage and Google BigQuery. So everything is written in one window. So data storage is also controlled by them, data compute is also controlled by them, and then you just write the SQL and they're able to pull that data. That is what I'm understanding from this, correct?
Yes, correct.
Okay. Yeah.
Okay, and it is commonly used where we use this. I can say for data analytics. Then BI, business intelligence. Then reporting and dashboard. And the real-time analytics. So we use this. And the key feature is, like as I told, uh, first it's a serverless and fast, fully managed. And built-in machine learning.
Yeah. Oh, that is always helpful. Yeah.
So the architecture, okay, BigQuery architecture. So what will be the architecture? The first is we are going to have a data source, right?
Yes.
Data source to data ingest. That is, I can say data ingest means cloud storage or data flow. Then it will go to BigQuery storage. Then SQL query engine.
Yeah.
Then dashboards.
Yeah. And that is for GCP, it is like Looker Studio or something you can use to
For
build a
studio,
dashboard
Tableau,
within that,
Power
right?
BI.
Tableau BI, yeah, Power BI. So anything else? So there's Looker, Tableau, Power BI, anything else?
I think this is the one mostly used.
Okay.
Core components, what is the core component? Uh, First is a project, then data set, then
Ta- Table,
table, view,
view. Yeah.
then job. And what is data loading uh, options?
Data loading.
Like you can load data from where, how you download the data. You can load data from cloud storage,
Cloud storage,
CSV
okay.
files,
CSV files, text files, uh,
JSON,
JSON, yes.
AVR.
What is AVR?
So, so one of the uh, you can one of the way to load the data
Okay.
directly.
Have
Then ORC, then Google Sheets. Then you can have any APIs. So, like there is a difference. Now we are having BigQuery versus traditional database, right?
Yeah.
So, how BigQuery is different from that? Because in traditional, when it comes to scaling, the BigQuery is automatic, but traditional database manual. When come to SQL support, in BigQuery we have standard SQL, but in traditional database only SQL. And
Okay.
BigQuery is best for analytics. Traditional database best for OLE transaction.
Got it.
Performance, BigQuery is very high for analyticals, high performance. Traditional database is better for transaction work.
So can you repeat that? Repeat that?
I just told difference.
Yeah,
Is
yeah, yeah.
which one? See, if I told about server management, in BigQuery, don't need any server. But in traditional database, we need a server.
Yeah, yeah, yeah. Yes.
Scaling,
So what is the advantage?
it's a serverless, right? You don't need to keep your server and uh,
Yeah, yeah,
uh, load all the data on server and ask the server permission, thing like that.
yeah, yeah. So which one is better for what use case? I think you
Big
said, right, like something use case.
BigQuery, yeah, BigQuery is better because in scaling, okay, in BigQuery we
Scaling.
have
Yeah.
automatic scaling. Traditional
Yeah, yeah, yeah.
database have only manual.
Correct,
SQL
correct. Okay,
support,
got it.
BigQuery have standard SQL, traditional only SQL, best for analyticals BigQuery, and traditional database for SQL for OLAP, that is OLTP transaction. Performance very high in BigQuery. Traditional means better for transactional workloads. So common use case where we use sales and marketing analyticals, the financial reporting, IoT data analyticals, and then website and application analyticals, log analysis, data warehouse. So these are the common use case. So next we can able to, we have some limitations also. What is the
Yeah.
limitation? Like,
Limitation is it? Mhm.
yeah, because in BigQuery is not designed for high frequency OLTP workloads.
Okay.
Cost can increase if queries scan large amount of data. Required,
Okay.
and you must have understanding of data partitioning and clustering for optimal performance. It's required.
Okay.
These are the limitations.
Got it.
Apart from that, we have a lot of advantage because no infrastructure management, handle very large data set, high speed analytical queries, then integrate with many GCP cloud service, support SQL, making it easy for analytical services advantage. This is how overall I told about BigQuery.
Yeah. Sounds good, sir. So can we go into query writing now?
How I don't have GCP account. So
No, we can do basic SQL also. Just like, select star, we'll just start from there because syntax is anyways like similar. Um,
yes, actually, which query you want? For example, suppose
so I think basic query, I know any example if you want to take and just teach join condition, right? We can start with joins. Any example, just take example, table names and just explain the join condition.
okay. Okay, let me write like this. Um, Basically, join condition. If join means what? You combine rows from two or more tables, right? Based on the related column. Okay.
Yeah.
So, for example, I'm writing here SQL. Select columns, okay, from every one. Then I'm going to select every two, okay, on uh, everyone dot form column equal to then table two dot. This is for example.
Okay. Can just explain this to me because I can, I'm mostly following what is here. So select columns from table one,
Because you
join table two.
join combines rows from two or more tables, based on the related column.
Yeah.
Okay, and here I have given the on. So the on clause in the join condition, it tells the query, okay, how rows from two tables are related. Okay, so that's why I given
Mhm.
this.
Okay. On table, so that just that last line, right? So you're joining table one, table two on table one dot. So that is the primary key. Is it common column?
Yes, yes. Primary key
Does it
of
ha
the column. Primary
does it
key.
have yeah, does it have to be the primary key?
No, without also we can.
Okay, okay. So you can join on any column, right?
Yes.
Okay. So it can be any column on both tables, or does it have to be key on one column?
Tell me again.
No, like so does it when you're joining two tables, right? The thing is, if it's not a key, right? Like there could be duplications, right? Within the rows, there could be duplications, and when you join, that will become a problem, right?
See, what these all things we will discuss generally when we are integrating two table because they have foreign key, right? So
Yeah.
they are like we are in like we are in like two tables we are taking like we have employee ID, okay, from the TMP. Suppose we are having uh, two tables, okay. So then this is not a matter like the two table have equal columns because you are differentiating in table one, table two, right? These two table name will
Hmm.
not match. That's all. So, for example, um, you suppose you want to see the department ID of EMP table, okay? That is from employee table and department table. So in employee table also you have department ID row. In the department table also you have that department ID. You understand?
Yeah.
Say this join.
No, see, the thing is, you're talking about like column name, right? So the column name is like similar, like the values are similar. But in terms of the records, right, like within that column, when you're joining, if the values are same,
That's why I'm telling. Values can be
yeah,
same. Table names are
okay,
different, right?
yeah, yeah,
So,
table names are different.
so it will work. Okay, because here the on clause in the join condition it tells BigQuery how rows from two tables are related.
Okay, so just one question, right? So table one dot common column. So that common column that is there, is that unique within that
Yeah,
table?
yeah. You think the table is a unique.
Okay, so it has to be so it has to be unique, but it doesn't have to be primary key, is it?
No, no need to have primary key. You can take any column from table one, table two. You can join and you can see.
Okay.
So, for example, you are having like PMP ID. or EMP name or department ID. Okay, so
Yeah.
again, and this is a sample table of employee.
Mm-hmm.
And we have another table called department. We have like department ID and partner. Maybe I can say for
Mm-hmm.
now how to write either join. So I use select e dot emp underscore name, then g dot department underscore name from an employee. Okay. Then I will inner join department is on the department ID go to. So like this you have to
Okay, got it. So sample table, employee ID. So employee ID is the primary key, is it?
yes.
Okay, and then so can you just explain the concept of like primary key and foreign key? Primary key, secondary key, foreign key, in very basic terms. Like just don't want like detailed explanation, but
Just
yeah.
okay. So you want to know the difference
Yes, sir. Yeah.
between primary key and
Secondary key, foreign key.
let me think. Okay, let me see. If I say primary key is a like it's a call, okay, or set of column that uniquely identify each row in the table.
Mm-hmm.
That is primary key. Unique for every row, cannot contain null, and only one primary key per table. For example, like employee ID can be uniquely identify each employee, right?
Mm-hmm.
Secondary key is a column used to search or group data, but does not have to be unique. It's called secondary key. So here department, right? The department, uh, uh, suppose can see this can be a secondary. Say this department, okay? Because multiple employees can belong to same department.
Okay,
Uh,
so is the sec like so all three keys will exist in all tables?
yes,
So all three keys will exist in all tables. So the first table, right? Sample table, table, employee. So which is the primary, secondary, and foreign key there?